we're going to have a look at patterns. Imagine we're making these little patterns out of matchsticks, and we want to figure out how many matchsticks would we need in order to make figure 100. So what we can do is just start by counting. So in figure 1 we've got 1, 2, 3, 4, 5, 6 matches. And then we could go to figure 2 and we could count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 matches. And then we could do the same count for figure 3 and go on like that. Now obviously that's going to be a problem in that by the time we get to figure 100, it's going to take us an awfully long time to go and individually count all those matches. So what we really want to do is be a little bit more intelligent in how we look at it. So we start to try and see what pattern there is there. So let me show you what I mean by this. If we look at figure 2, you can see that in figure 2 you've taken the little house that was in figure 1 and then you've added on 1, 2, 3, 4, 5 more matches. So you've got 11 matches. Taken the 6 that were in figure 1, added on 5, and you get to 11. And then if you have a look at figure 3, here you have all the matches that you had in figure 2, and then you added on exactly the same, 1, 2, 3, 4, 5 more. So what you're going to have here is you're going to have 16 matches. And then you can quite easily picture what would happen for figure 4. Because if you picture figure 4, it's going to have everything that was in figure 3, and then you're going to put on those 5 more matches around the side, and so you're going to have 21. And this sort of way of seeing a pattern is going to help us figure out how to get to the 100th, how many matches are in the 100th pattern. So now if we just put down carefully the structure of what we were seeing, we can get to a formula which will help us to determine the number of matches in any figure. So what we saw is that what we were adding on each time was this little picture of 5 matches. So what we can say is in figure 1 we had this 1 match plus 5 matches. Now in figure 2 we had the 1 match and the 5 matches, and we've got another 5 matches. In other words, we've got 1 match and 2 lots of the 5 matches. When we get to figure 3, we've got the 1 little match here, and then 1, 2, 3 lots of 5 matches. So then we can quite easily figure out, well, what will happen with figure 4? Well, you're just simply going to be putting on another lot of 5 matches to the end, so you're going to have the 1 plus 4 lots of 5 matches. So for figure 100, how many matches will you need? Well, it'll be 1 plus, and in this case you're going to have 100 of those little lots of 5 matches, and if you actually want to get the real answer to that, it's 501. Now what we want is a general formula. We want to say for any number, well, how will we work out the number of matches? Well, it'll be 1 plus n lots of 5, right? Because if we had figure 2, it'll be 1 plus 2 lots of 5. For figure 3, 1 plus 3 lots of 5. For figure 100, 1 plus 100 lots of 5. So for figure n, it'll be 1 plus n lots of 5. And then just to write that nicely in terms of algebra, you remember that in algebra we write n times 5. Typically we just write that as 5n. And more conventionally, we'd write it as 5n plus 1. So this formula can easily help us then if we wanted to know how many matches there were in figure 20. We would just say it is 5 times 20 plus 1, which is 101. Okay, I want you to try this one. Open your homework books and see if you can figure out for me how many dots there'll be in the 4th figure, the 10th figure, and the nth figure. Hopefully what you noticed is that each time you went to a new figure, you were simply adding on 2 more dots. So you can see that in the first figure that we have here, we have the 3 dots in this that make the sort of central line, and then the 2 extras on either side. And then in the next figure you've got the 3 in the center, and then you've got now 2 lots of 2 dots on either side. And then in the third figure you've got the 3 in the center, and then you've got 3 lots of the 2 dots on either side. So this gives us an easy way to then say, well, what would happen with figure 4? Well, you'd still have the 3 in the center, but now you'd have 4 lots of 2 dots on either side. And in figure 10, you would have the 3 in the center and 10 lots of the 2 dots on either side. And obviously we can get these to real numbers, right? This is 5 in the first figure, then you've got 7 in the second, and then you've got a 9 in the third, and then you've got 11 here, and you've got 23 in figure 10. If we wanted to get figure n, well, we're just following that pattern, right? You've got the 3 in the center, and now you'll have n lots of 2 dots, which we can write nicely as 2n plus 3. And now once we've got that formula 2n plus 3, which tells you the number of dots in any figure, we can go and use that. So say we could work out here, if we want to know how many dots there are in figure 20, we can just go substitute in the formula. 2 times 20 plus 3, and that's going to give me 43 dots in figure 20. But we can also answer the question the other way. We can answer which figure has 63 dots. And here we will say, well, we want to know what is the value of n when we've got 63 dots. So we'll make an equation like that. We'll then be able to solve this, subtract 3 from either side, and then divide either side by 2. So we'll know that it's figure number 30 that has 63 dots. Okay, let's look at what we've observed here in order to help us get answers to patterns questions much more quickly. So if we have a look here, when we did this one, right, we noticed that each time we went up, we were adding on 5 more matches to the pattern, right? So from figure 1 to figure 2, figure 2 to figure 3, we're adding on 5 matches to the pattern. And we came up in the end with a formula of 5n plus 1. So when we were adding on 5 each time, we came up with a formula 5n plus 1. Now in this case, we added on 2 extra dots for each time we moved up in the pattern, and we came that this pattern had a formula 2n plus 3. So when we added on 2 each time, right, the nth pattern will have n lots of 2 dots plus 3. This, if we observe that when it's adding on 5, we get a 5n, adding on 2, we get a 2n. It's going to help us get to the answer for patterns very quickly and easily. So if we have a look at this pattern, we can see easily that in figure 1, there's 1 dot. And when we go to figure 2, what we've done is we've added on 4 more dots. So we have 5. And then when we go to figure 3, we've added on another 4 dots around the edge. And so we've got 9. So now we know from what we've just observed that if we're going to go to figure n, it's going to be 4n, and then we're going to have plus something or minus something after that. So we've got to figure out what. So this one here, for figure 1, it's 4 times 1, and then it's plus something or minus something, must give you the answer of 1. And then here, this one, it's going to be 4 times 2 because it's figure 2, and then it's plus something or minus something must give you the answer of 5. And here 4 times 3, and it's plus something or minus something must give you the answer of 9. So let's try and figure out what that plus something or minus something is. Well, 4 times 1 is 4, so to get to 1 I'd have to subtract 3. And let's just check then. 4 times 2 is 8. Yes, if I just subtract 3, I do get to 5. And 4 times 3 is 12. And if I subtract 3, I do just get to 9. So I know my formula then is 4n minus 3. So in other words, in figure n, there's 4n minus 3. This helps me then if I want to know what happens to figure 100. It's going to be 4 times 100 minus 3. Which is 400 minus 3, which is 379. Now, our patterns don't always have to come as pictures, so we could, for example, have a pattern which is just in numbers. So it goes, as it goes up, 4, 10, 16, 22, 28. So the first term in our pattern is 4, second term is 10, the third one is 16, the fourth one is 22, and the fifth one is 28. And if we want to work out now what, for example, would be term number n, a formula for that, and that will help us get to figure out, say, what is term 100. We can use exactly the same idea that we've just been using. So we can observe to go from there to there is a plus 6 each time, right? Each time you're going up, you're adding on 6 more. So we know from what we've just discussed that our term n will be 6n, and then it's going to be plus something or minus something. And we go back here to work out what, right? So for term 1, it would have been 6 times 1, and then we've got to do plus something or minus something to get us the answer of 4. And hopefully you can see quite easily that that should just be taking away 2. Let's just check because it's got to work for every term. This would be 6 times 2, it's 12, and if we subtract 2, do we get 10? Yes, right? And we could carry on checking, right? This one would be 6 times 3 is 18, minus 2 does give me 16. So this minus 2 we now can be pretty sure is what needs to go on for term n. So 6n minus 2. And then to get term 100 is easy. It'll be 6 times 100 subtract 2, which is 600 subtract 2, which is 598.